pick the encoder-decoder sandstone to train the model. And pick a target data pile version from the piles that is in .data. .ai allows training with computing resources across the hybrid cloud. In this case, it runs on IBM Vela. Vela is a first-of-a-kind cloud-native AI supercomputer that we built last year. It gives you bare metal performance in the cloud with a virtualization overhead that is less than 5%. And we're making it available as a service. watsonx.ai autoscales the resources for the training being done. And the first thing that we need to do is to tokenize the data according to the requirements of the model. So we first query the data using the version ID for the pile we want to use. That materializes a copy of the data set on Vela for tokenization. What this means is that, for example, if we're building a large language model, the sentences in the data are broken into tokens. And this process can create trillions of them. And we use the tokens to train the model. Now, training is a very complex and time-consuming task. It can require dozens, hundreds, even thousands of GPUs and can take days, weeks, and even months. Training in Watson.ai takes advantage of the best open source technology out there to simplify the user experience. Built on Codeflare, using PyTorch and Ray, it also integrates Hugging Face to bring you a rich variety of open formats. Once training is done, the model is ready for validation. So for each model we train, we run an extensive set of benchmarks to evaluate the model quality across a wide range of metrics. Once the model passes all the thresholds across the benchmarks, it is packaged and marked as ready for use. For each model, we create a model card that lists all the details of the model. We will have many different models, trained on different piles with different target goals. Next, we go to watsonx.governance to combine the data card that has the detailed provenance information for the data pile that was used for training with the model card that has the detailed information on how the model was trained and validated. Together, they form a fact sheet. This fact sheet is cataloged in .governance and all the other fact sheets for all the models that we have available for use. Now, let's go on to tune the model that we just created. And what we mean by that is to adapt it to new downstream tasks, which is the basis for the large productivity gains that is afforded by foundation models. So say, in this case, you're a different persona. You're the application developer. So you can access watsonx.ai and start by picking a model from the catalog to work with. We have a family of IBM models specialized for different domains. But we also have a rich set of open models because we believe in the creativity of the global AI community and in the diversity of models it offers. And we want to bring that to you. In this case, we picked Sandstone.3b from the IBM language models, which is the model that we just trained. We set up the options for tuning, the tuning approach. We picked summarization as an example as the base model to use. Now we can access and use business proprietary data to tune the base model and for the task that we choose, whether that business data is located in anywhere in the hybrid cloud platform. So now we send prompts and tuning data, and that's used to tune the model in .ai. You get the outcome of the prompt on the model. This process happens back and forth many times, and in the end, you end up with a set of ideal prompts to use. The model is now specialized and ready to deploy. This is the final step in our AI workflow. The application where you want to use the foundation model can live in the public cloud, it can live on-prem, or on the edge. And you can really deploy and run foundation models efficiently wherever you need them. And the deployed model can be used in many different applications. So for example, we've embedded foundation models in Watson Assistant. For text generation in Assistant, you describe the topic that you want the assistant to handle, and it generates the corresponding conversational flow. We have an inference stack to scale the serving of the model in applications. It consists of state-of-the-art technology that has been field tested for scalable model serving. This is how Watson X allows us to go from data to a model that is trusted, governed, deployed, and ready to serve, and how we can scale that model to different applications. Once models are deployed, we continuously monitor them and update them in both .data and in .ai. We call this constant process our data and model factory. As watsonx.governance monitors the models, if there's any change that may impact how the model can be used or performs, be it driven because we have new data that can be leveraged, or there's a change in some regulation or law or data licensing. Any change detected by the .governance process guides and processes the update to both the data and the model. The idea of the model factory is that that is central to solid and proper governance of AI. Now, all of these updates need to happen without disrupting the underlying applications that are leveraging the foundation models. And this data and model factory is in production today. We have already produced over 20 models across modalities like language, code, geospatial, and chemistry, and spanning different sizes of models from hundreds of millions to billions of parameters. We've infused these foundation models into IBM products, Red Hat products, and our partners' products. At IBM, over 12 foundation models are powering our IBM NLP library, which is used in over 15 IBM products and is available to ISVs. Granite models trained over code are part of IBM Watson Code Assistant, which has been applied in the Red Hat Ansible automation platform. And as you heard earlier in this event, SAP has partnered with us and is infusing foundation models into their solutions. So Watson X is really ready for you to create value with AI. Now, to maximize what you can do and the innovations at your disposal, we believe that you should bet on community. Because the truth is, one model will not rule them all. And with the innovations and models that it develops, the open community is supercharging the value that you will be able to create. To be true to our belief in the diversity and the creativity of the OpenAI community, we're proud to announce our new partnership with Hugging Face. So let's invite to the stage co-founder and CEO of Hugging Face, Clem DeLong. Clem.
Hey, Dario.
Clem.
Thanks for having me.
First of all, welcome to IBM Think. We're just delighted to have you here. So let's begin by tell us a little bit about yourself and how and when you got interested in AI and how did Hugging Face get started?
Yeah, thanks so much for having me. I actually started in AI almost 15 years ago. I look at the room at the time, we couldn't have filled it. Maybe it would have been 1%, 2% of the room at most. As a matter of fact, we weren't even calling it AI at the time. We were calling it computer vision. I was working at a French company. I'm French, as you can hear from my accent. And we were doing computer vision on device, on mobile. The company went on to get acquired by Google after, but I never lost my passion and excitement for AI. So 7 years ago, with my co-founders, Julien and Thomas, we gathered around this passion for AI and started Hugging Face, right? What you see on my t-shirt, basically. We started with something completely different. We worked on conversational AI for 3 years. And as it sometimes happened for startups, the underlying platform and technology ended up more useful than the end product. When we started to release part of it on GitHub, we started to see open source contributors joining us. We started to see scientists sharing models on the platform, leading to what Hugging Face is today.
So I mentioned the power and the creativity of the open community creating an AI. just share with us some statistic. How big is it? How much energy is there in that community?